Hello! So today we're going to be doing 7.37 from the homework. This is the presentational video version of it. So basically we have a box that weighs 80 kilograms, a bag of concrete. Just imagine this little cloud is concrete that weighs 50 kilograms, and then it's going over a very light string. This is a frictionless pulley, and then we have a bucket of concrete that weighs 65 kilograms. So, and the other numbers that are given to us from the book is the coefficient of friction static is 0.7 and the coefficient of friction kinetic is 0.4. So question A is asking us how much friction is there between the box and the gravel force, like what is the frictional force between these two objects. And part A is really easy to answer. There is zero frictional force. 0 newtons of friction, mainly because the box isn't moving, and if the box isn't moving, then there can't be any friction between the gravel and the box. It's just the normal force acting on the acting on the gravel. Part B. So basically, what part B is asking is a worker comes up and picks up the gravel very quickly, and we want to use the energy conservation equation to know the speed of the concrete bucket after it descends 2 meters from rest. So we're going to assume that this line right here is rest. It's going to fall 2 meters, and we want to know what the velocity is at that 2 meter question mark there. We want to know what the velocity is there. So to go ahead and do this, we're going to go ahead and use our friction equation. So let's go ahead and erase part A for some room. So the friction equation basically says friction is equal to our coefficient kinetic, which is 0.4, multiplied by the mass of the box, which is 80 kilograms, and multiply this whole thing by the gravitational acceleration constant. So let's go ahead and plug these numbers in. We get friction is equal to 0.400 multiplied by 80 kilograms multiplied by 9.8. Then we get this as an answer of 313.2 newtons. The next part we want to go ahead and do is to use the energy conservation, and to find energy conservation we need to know the change of energy. So delta U is equal to, because the concrete box is moving in the downwards direction, we're going, in our reference frame, we're going to call this to be negative. It'll be negative the mass of our concrete times the acceleration constant multiplied by our distance that it dropped, which is 2 meters. And once again, we just plug the numbers back into it. So negative mass of concrete 65, gravity is 9.8, and the distance is 2. And you get the final answer of negative 1,274 joules. And this is our change of energy. And finally, using all of that, next what we want to go ahead and do is find the work done, the frictional work of the box on the flat surface, I guess you can call it that. And so the frictional force is super easy to find. It's literally, because once again we're going to consider this as the negative direction because it's moving that way. We have negative Fd, and let's go ahead and multiply this out. We got the force earlier, the frictional force, negative 313.2. And multiply that by the distance it traveled. So this goes down 2 meters, it goes by 2 meters as well. We got 2. And once you answer this, we get negative 626.4 joules. Finally, we're going to go ahead and use the work energy equation. So the work energy equation basically is 1/2 the mass of the box plus the mass of the concrete times the velocity squared, or solving for velocity once again, is equal to the negative change in u, which we found over here, and we multiply that by the work, the frictional work. And so go ahead and we'll rearrange this to solve for velocity. We get that velocity is equal to big old square root 2 times negative delta U plus our frictional work, and we divide this entire thing by the mass of the concrete of the box and the mass of the concrete bucket. So MB plus MC. And I went ahead and plugged everything in prior to this, but basically what you would do, you would do 2, you have negative change of U, so negative times the negative, you have 2 times 1274 plus negative 626, so you add those, multiply by 2, and then divide it by 65 plus 80, find the square root of that, and we get a grand answer of 2.98 meters per second. So basically what that means is that once this concrete bucket drops 2 meters, the velocity of the concrete bucket at that position will be 2.98 meters per second.